What is the most used man-made material on Earth? You guessed right. It's concrete. Look around. It's everywhere. Sidewalks, driveways, foundations, floors you stand on, and even entire buildings are made out of concrete. So why don't we discuss it more? In each episode of Concrete Logic, we will explore one concrete-related topic with the help from industry professionals that are shaping the future of the trade. We'll talk with suppliers, contractors, architects, engineers, specialists, and even some proponents of competing materials about their views of concrete and their vision of its future. And welcome to another episode of the Concrete Logic podcast. And today I have some folks from Forta. Kristin, you want to start us off and tell us a little bit about yourself and then hand the mic over around the table?
So today we have Gerry Welch and Bill Coursen here with us today.
I'm Bill. I'm the Vice President of Sales.
I'm Gerry Welch. I'm Director of Engineering Services.
Yeah, and so I asked Kristin to come on, and she brought all the troops with her. So that's awesome. Thank you, Kristin. Yeah, so obviously Forta is, since we got you on the podcast, we're going to talk fibers. That's what y'all are known for. So I was hoping that we could talk about the origin of Forta. Y'all have been around for since 1978, I think is what I saw. Could you all talk about how you got started?
Sure. I can give you a little bit of overview on Forta here. Back in the late 70s, Mr. Roger Lind, the founder of Forta, he was actually at dinner in Pittsburgh, and a gentleman at the time had a handful of these fibers, and he was looking for someone to be a distributor here in the U.S. for them. And Roger got to talking to the gentleman and really kind of was intrigued with this product, these synthetic fibers. So Roger eventually went back over to Switzerland and met with the company. And really a long story short, he ended up buying the company in Switzerland and bringing the company and all of their manufacturing equipment here to Grove City, Pennsylvania, and started Forta Fibers in 1978. And so really, I mean, fibers have been around here in the States for 40 plus years now. And I mean, I know just a little bit more background, interesting story. My mentor, Dan Biddle, he's retired now, but the very first bag of fibers here sold in the States was into precast bird baths. Fibers have come a long way since 1978, where from selling into precast bird baths now into industrial and commercial floors and pavement.
Yeah, I was going to ask you what that company was doing with the fibers way back then. Is that what the Swiss company was doing?
Yeah, I mean, the technology came from Europe and was brought over here by Roger Lind to be used in the States. And now it's 40 plus years. It's used worldwide in numerous different applications, like I said, from interior floors to metal decks to pavement to precast.
And then from there, I mean, as far as being mainstream, is Forta or fibers in general, when do you think they hit mainstream? Because like I was sharing with you all, I've only been aware of fibers and concrete the last probably 4 or 5 years and actually used them. When do you all have seen them as far as being more mainstream?
Yeah, originally the first original fibers were microsynthetic fibers, and then really where you start to see fibers take off is when we introduced macrosynthetic fibers to the industry a number of years later. And that's where you start to see the fibers kind of go mainstream, because now we're getting into the replacement of your heavier wire mesh and rebar as temperature shrinkage reinforcement. So once macro fibers hit the market, that's where we started to see the industry kind of really take off with the use of fibers.
Seth, I find it funny that you feel fibers just hit the mainstream recently, because actually fiber reinforcement has a longer history than concrete. Actually, fibers go back to as far as Mesopotamia and Egypt, like 1200 BC, and actually before Roman concrete was even invented. This is how long ago it is. Portland cement was only invented in 1824. We have actually fibers being used in the Alamo in 1718. So fibers go through there from a natural standpoint, and then in the turn of the century, we started using synthetics and glass coming in the 60s. And so where we actually brought this to the U.S. market in like we said, 1978. Currently, from the 2000s on is where we're seeing this macro fiber being used in the industry worldwide.
Mm-hmm.
Yeah, no, now that you say that, I see what you're saying as far as it's been around for a long time. But
Right.
I guess in my world, it hasn't been around a long time. So we're already spouting off some terms here: macro, micro fibers. I think this would be a good segue into, let's explain what those are. So if we could start with microfibers. What are microfibers, and then what are macrofibers?
Sure, actually, the delineation on fibers is actually under ASTM ACI is actually the measurement of 12 thousandths of an inch in diameter. That's the break point. Anything below that is considered a microfiber. Anything above 12 thousandths of an inch in diameter is a macrofiber.
Yep. Another explanation would be your microfibers. You really have two types. Micro being a monofilament, short, smooth, round fiber, typically 1/2 inch, 3/4 inch long. They're used for plastic shrinkage reduction. A typical dosage with these micros might be 1 pound per cubic yard of concrete.
We talk about it being fine angel hair, millions of pieces per pound.
Mm-hmm. Yep. And then the other would be your fibrillated fiber. And when we say fibrillated, you can kind of actually open these up like a screen or like a mesh. When you mix them into concrete, they open up, they help with plastic shrinkage as well and give you a little bit of hardened concrete benefits. And then when you really get into your macro fibers, the macro fibers are a longer, heavier duty fiber where we're getting into the replacement of your heavier steel like road mesh and number 3, number 4 bar, that type of thing.
I think to kind of give you some presence of mind, this past year, there was 33 million pounds in the domestic market on fibers being used, roughly, I think, what we know, and around 30 million on micros.
Mm-hmm. Yeah. And back up a little bit. I mean, what we're getting into is, again, the replacement of traditional steel reinforcement. And as you know, Seth, you've been in the field. I mean, wire mesh and rebar can be difficult to work with. I mean, you have to put it on chairs and you have to make sure you get it located properly within the cross section of that concrete. We've all seen instances where the concrete truck's driving over the mesh and pushing it down to the ground. So with fibers, I mean, you just mix them in the back of the ready mix truck and your reinforcement is already in the concrete. So it's a lot easier to work with.
Yeah. So is it, first off, I guess first question I got, is the micro and the macro fibers, are they made out of the same material?
They can be. A lot of propylene, actually, synthetics can be anyone from polyethylene, polypropylene, an acetate fiber. So really, most microfibers are polypropylene or nylon fibers. Mm-hmm. A macrofiber is traditionally, polypropylene. Can be steel fiber, can be natural fiber, actually not microfibers, but natural fibers for micro.
I'd say probably 95% of the U.S. market utilizes polypropylene. The nice thing with polypropylene is chemically inert. I think it takes 95% concentration of hydrochloric acid to start breaking down polypropylene. And at that point, if you have that much hydrochloric acid on the surface of your concrete, you got bigger things to worry about than the fibers.
I think a better way to think about it is majority of the fibers in the market are plastic. That's really where we're at. Mm-hmm. Some derivative of plastic.
And as far as, so with the microfibers, just speaking from my experience, the microfibers would be more of a supplement to, I guess, your standard reinforcement, your steel mesh and rebar. Is that a correct statement?
Yeah, typically micros are only used typically for plastic shrinkage control. At the very surface, we're having some cracking occurring because of either humidity levels changing or high winds causing that the very skin of the concrete to harden and crack early. So that fiber helps keep that crack together at a micro level. So this is where we're seeing that application only. And that's the only purpose of that fiber is to work for the first 24 hours of the concrete's life. After that, once the concrete's hardened, that fiber has no other benefit. So we go to the macro. The macros are doing the plastic shrinkage control, but actually have additional benefits in the concrete, such as, again, toughness of the concrete, post-crack capacity. That's where we're going to get other benefits going on.
Mm-hmm. Yeah, with the angel hair monofilament, the microfiber, we don't recommend replacing wire mesh with that fiber. When we get into the microfibrillated fiber, we can start looking at replacing a light gauge wire mesh. And then when we get into the heavier steel, that's when we're looking at using macro synthetic fibers.
Understood. And then, so that was interesting. I never thought of the micro, just it being its use cases for the initial curing of the concrete. I think that might be surprising to some folks.
Mm-hmm.
At least,
yeah, I mean, it goes back to what Bill had said earlier, that the monofilaments, once they're smooth and short in length, if a crack were to occur, there's no increment, so there's going to be no post-crack capacity, no benefit.
Yeah. If you visualize a short angel hair monofilament fiber to something like a finish nail, and you take two pieces of wood and you tie them together, or you nail that finish nail into the two pieces of wood to anchor them together, it hides very well. But the problem is it doesn't really have any way to anchor those two pieces of wood together very well. So it's pretty simple to get those pieces of wood separated. So if you think about that finish nail like a monofilament, a fine monofilament, and then if you take that fibrillated fiber and picture it as like a screw, and you screw those two pieces of wood together, it's a little bit more difficult to get that wood apart because you deformed that material. Similar to you deform that steel from a finish nail to a screw.
Yeah, that's a good way to envision that. The microfibers and the macrofibers, are there like different types within each one of those groups?
I mean, there's different chemistries, really. I mean, like Gerry had mentioned, your micro monofilaments are made from nylon, polypropylene, polyester, cellulose. Fibrillated fibers can only be made from polypropylene. That would be your only choice. You can't take a fibrillated fiber and have it made from nylon. It's only made from polypropylene.
I think the best description is not all fibers are equal. We have that ability, the small fibers, small in length, small in numbers, gives you, or small in diameter, the micros, you have millions of pieces. Going up to the macro fiber, you have different shapes, you have cross sections, length of fibers, the chemistry of fibers. Those all add up to give different performances. The modulus elasticity, how rigid or stiff that fiber is. So this all culminates in not every fiber being equal to other fibers.
Okay, I understand that. I got a kind of a dumb question. Here,
No such thing.
On this podcast, there is. When the fibers are specified, there's a dosage in there per cubic yard, and it's by pound. So is a 5-pound dosage of microfiber in a 5-pound dosage of a macrofiber? Is there a difference other than we already talked about one's just for the initial curing and the surface cracks, preventing those? That's the micro, and then the macro is more of a structural.
It's a good question. Actually, I think keep in mind 5 pounds of a micro monofilament would be like trying to shove a pillow in the back of a concrete mixer, multiple pillowcases with feathers and trying to mix it all up. And then 5 pounds of a macrofiber is like, again, we're going to put nails in the back and get this mixed in. Performance-wise, you're going to see a big difference because, again, you're not going to see a post-crack capacity with the microfibers. You're going to have mixing challenges with the microfiber. The macrofiber, you should be able to have mix 5 pounds with no problem, most fibers, and have a good, tough piece of concrete when you're done with it.
Mm-hmm. Yeah. To that question, we knew for years with the microfibers, if we could get a higher dosage into the concrete, we would get better performance. The problem was trying to get 5, 6, 7 pounds of angel hair monofilament or fibrillated into that mix and get it to mix properly. And that's why what Jeff Lovett with Forta and others went into research and development to find a fiber that we could get to mix and finish properly. And so with our macro fiber, that's what we were able to do, was to increase the performance, was introduce our macro fiber that you got very good mixing and very good finishing. To try and do both of those, mixing and finishing with a microfiber at those types of dosages, you'd have a lot of fiber balls and you'd have difficulty getting those fibers to finish properly. That's kind of really the onset of the introduction of macrofibers, because we could get a higher dosage of fibers into the concrete and get better performance.
Yeah, I think we're going to see difference between micro and macros. I'm going to get increased toughness, ductility, better, more abrasion resistance. Permeability rates will drop, and swallowing and freezing performance will increase.
And that's with macro versus fiber. Macro. So if you wanted to control shrinkage cracks, are you saying the macro would do a job as good as the micro? Or, how would you address that?
Better. You framed it correctly. We're controlling the cracks. We're not reducing, but we're going to be controlling the cracking that's going on in the slab at a micro level. We want to intercept those cracks at the micro level before they become a macro crack. We're using macro fibers to attack the micro cracks.
Okay, so you would never have a mixed design where you have both macro and micro in it?
No, you could. By all means, you could, because again, if the conditions of the job are requiring to have a macro fiber, you just want that extra assurance. There's no harm putting in a pound of a microfiber to help you control your plastic shrinkage. Macrofibers are going to give you some plastic shrinkage, but really that fiber is intended to be for crack control or toughness. That's what we're looking for. So we do have clients that want to see a blended fiber.
So would you suggest for best practice, if let's say you're doing a slab on grade or slab on ground, wherever in the country you're from, you call it different, but if you were to place the typical steel mesh that you see in like a slab on grade in a building or office building or garage or whatever, and they want to replace it, would it be best practice to just replace it with macro fibers versus micro? Or
that's what I would recommend. Is, again, if we have the ideal conditions of a standard job going forward, there was only requirement to use a macro fiber to replace traditional reinforcement.
Mm-hmm. Yeah, I guess really macro fibers can do what micro fibers can do, plus we are doing more with macro fibers, like we talked about, because you're using a higher dosage. Macro fibers are typically 3 to 7.5 pounds per cubic yard, where a microfiber would be 1 to 1.5 pounds per cubic yard. So what the microfibers can do, the macrofibers can do as well, but also increase, like Gerry had mentioned earlier, your toughness, your durability, your residual strength of the concrete. You're getting a lot better performing fiber with macrofibers.
Okay. Thank you for straightening that out for me. We talked about briefly, we've mentioned it a couple times here, that macro fibers can replace your traditional reinforcement mesh and rebar. Is there a limitation to that? Like, what size bar could the macros replace? I guess if you wanted to replace them all.
I think it's better to look at not looking at the size of the bar, but more the application. What's the intended use for that steel reinforcement is. If it's for structural purposes, that we do not recommend doing that. Again, we're going to get benefit to the concrete itself for post-crack capacity. Engineers really need to take that into account when they're doing their design work. But again, if it's a structural in nature, that steel must remain. Again, temperature shrinkage, all day long, we could be replacing that, no matter what size mesh rebar it is. If that's the intent of what that reinforcement is for, that's what we need to do. A good case in point would be those who know composite metal decks. SDI allows you to use 4 pounds minimum of a macro fiber for temperature shrinkage control. Yet the negative moment that occurs over the beams and girders, you use that rebar. You can replace that, but it'd be very high dosage because you're putting that rebar into bending or mesh, whatever's being used on the composite metal decks. But it doesn't become economical from an overall fiber supply purpose. But again, you want the crack control out in the middle of the panels. That's what the fiber's doing. And you strategically put reinforcement above your negative moment region.
And Seth, we have done a hybrid as well, where the steel, it might be the steel's in there for structural, but they'll also include fibers for crack control.
Yeah, there's a large retailer out there that requires that on all their projects. Mm-hmm. But as far as going, I'm sorry to beat a dead horse, but going back to the slab on grade. So I understand what you're saying on the metal decks, that there's other forces that happen on a elevated deck like that. Macro fibers wouldn't be able to replace everything that happens on that.
Well, it does happen in the slab on ground too. Again, if the slab is a structural slab in nature and the rebar is being used for bending stresses, it's going to be difficult to equate that to fiber and a dosage. It would just be so high, it wouldn't be a practical solution. But again, we have to work with the engineer of record and understand the design and what's going on functioning with that rebar or mesh.
All right. And then as far as I was poking around on your website earlier, I guess the main focus in the industry today is being sustainable. You all have a product out there. It's actually made of, it looks like recycled material. Did I see that right?
There is. It's a ferro green. It is a recycled material. We do make, actually, I think more sustainability is just fibers themselves. It's synthetic fibers are actually more sustainable than the steel reinforcement for today's applications for slab on ground. Most good companies will show you they have EPDs. I'm sure we hear that buzzword in the industry a lot for sustainability. I need my environmental product declaration to tell you how your greenhouse gases are accumulated. Good companies will have those certificates to provide to the producers to give to the architects and engineers.
Yeah. Are you all supplying that for your products?
We are one of the few that have an APD available.
Okay. And then, I'm still learning I think we're all still learning what to do with those things.
I mean, it's the responsible and the right thing to do. It's out there. So the EPD comes with a life cycle cost analysis so they can account for where all your production is coming from, and the carbon monoxide is being produced.
So is all y'all's products, are they manufactured in Grove City?
And I think it's important to remember. Oh, sorry about that, Seth. Go ahead.
I was asking where your products are manufactured.
Mm-hmm. Yep, Grove City, Pennsylvania. And like I said, we ship worldwide.
I was just asking that because of that's, having something that's locally sourced, manufactured is, I guess, a concern as well.
I think that's more on the LEED applications for projects with LEED certificates and going credits.
I was saying, I guess, like I was getting at, we're all learning what these EPDs are and how to utilize them, but I think knowing that the product that you're specifying, even if it's not a LEED credit, if you're still not trying to, even if checking off that box isn't important to you, I think having locally or regionally sourced products on your project would help out as far as your carbon footprint.
Certainly. Yeah, definitely. Again, transportation is key in the projects. Sure.
The reason I bring that up is right now, internally, we're discussing that, how to reduce the carbon footprint on the projects that we're a part of. And it might not necessarily be just this piece of paper says this is, this EPD checks all these boxes and is better than the baseline. Right. It's also actually, to me, doing the things that are kind of logical as far as things that you can do that I guess you can see the result of that effort. Like if you're shipping things down from Pennsylvania down to Virginia, that's obviously you can see that happening versus, hey, I am shipping the same product from overseas on a cargo ship, and the implications of that as far as your carbon footprint.
Yeah.
Mm-hmm. Certainly.
I'm just bringing that up because it seems like we get lost in, like you all have offered that you all provide these EPDs, and I'm not too sure if everybody knows what to do with those things. I would rather say, hey, this product that you're specifying we got to import it. It's coming in from overseas. It's going to come in on a ship. Or you can specify this product that's made, 5 hours up the road.
I'll say I know this part of that. I think where you're getting is the EPD has to be certified by a third party, and that's what we've actually been able to accomplish, because they do take all the information plugged in and validates the information that was accumulated, where it's being manufactured, the transportation costs. So you can have an EPD, but you want the EPD that has been independently certified.
Yeah. I'm skeptical of the whole process. I just think somebody's trying to make some money off of this whole thing. But the good thing about, like you all have been kind of getting at here, is if you use macro fibers and you're able to reduce the amount of rebar reinforcement that's in a slab or a deck or whatever, you're reducing, again, the carbon that steel would produce, right? So that's good. But also you're reducing the amount of labor. And if you're reducing the amount of labor, in theory, your schedule for your project should be shortened.
Definitely.
And if you're shortening your project, that means someone made this point on a previous podcast, but if you're shortening your project, that means less equipment out there idling and burning fuel and all that other stuff that is apparently terrible for the atmosphere. So I think that's the kind of thinking that we need to have versus, hey, this piece of paper says my product is green. It's awesome.
Mm-hmm.
Oh, yeah. But I think you need that the starting point to be the understanding where you're getting the best benefit from a constructability standpoint.
Yeah. You still got to build the project, right?
Correct.
Well, was there anything else that we didn't hit on as far as what's important? You know what I was going to ask you? What are some of the mistakes that you see folks do as far as utilizing fibers?
Yep.
It could be the application as far as design. It could be, obviously I'm a concrete contractor, finishing and things like that. What mistakes do you see out there that folks make?
Yeah. Having been in the field for a number of years and seeing a lot of applications go down, I guess really you kind of need to start at the beginning, and that's when adding the fibers, because with macrosynthetic fibers, you're using 3, 5, 7.5 pounds per cubic yard. You got to make sure that the fibers get mixed thoroughly throughout the entire concrete mix in that drum. So let's just say you're using 5 pounds per cubic yard of a macro fiber, you got to make sure that when you add those fibers at the batch plant, that you bring that drum up to mix speed and mix those fibers for roughly 4 to 5 minutes so that the fibers have a chance to get down into the mix, open up, and properly break apart and get throughout that entire mix there. So that's very important. A lot of times I see where the driver might throw it in the drum of the truck and think, okay, I've got a 30-minute drive to the job site. That'll be plenty of time to get the fibers to mix. That's really not the case at all. You need to make sure that drum is at mix speed so you get that shearing action to get those fibers dispersed and opened up in the mix and everything. And then the other thing that you run into, particularly with a high dosage of fibers, is, let's just say the contractor wants a 5-inch slump. We'll just use that. And you add macro fibers in there at 5 pounds per cubic yard, it might knock that slump down to a 3-inch slump. What we don't want the contractor doing is adding extra water. That the fibers are only holding that mix together. They're not absorbing any water or anything. If you add energy to that mix, it's going to act more like a 5-inch slump when you hit it with energy. We don't recommend adding extra water to get it back to that 5. If they really do need it at a 5-inch slump on the ground, then use some type of chemical admixture, whether it be a Super P or polycarboxylate, something like that, to get it back to that 5. I mean, if you were to pull that fiber out of that mix, it would go back to its 5-inch slump. It's just the fibers are holding it together. You need to, I run into that quite a bit whenever I have people telling me, well, the fibers are drying the mix up. It's not drying it up. It's just holding it together because you've got those fibers in there holding everything up there. When it comes to the mixing, or pardon me, the finishing, you've seen it, Seth. Now, not every fiber is created equal, like Gerry talked about earlier. There's a number of different macro fibers out there, and every manufacturer is going to have their own recommendations. But with ours, I mean, it really has kind of gained a reputation as one of the better mixing and finishing fibers on the market. When you're using a power trowel, I mean, these fibers do get pushed down into that concrete when you're doing interior work, and they hide very well. Really, interior work, I mean, I've had contractors who have never used macro fibers before in their first job, and they use 7 pounds, and they come afterwards and say, that really finished really well. I'll use that again. Broom finishing for pavement, it is a little bit different. I mean, there's some tips that we recommend because fibers are 3-dimensionally dispersed throughout the entire mix. You are going to have fibers on the surface. You just can't get around that. When you're brooming it, I mean, what we recommend is making sure as much as possible, but I know that you can't do it in every situation, is brooming in one direction. That way you're laying the fibers down. What happens is when you lay them down in one direction, if you pull that broom back across that area you just did, you're going to start pulling the fibers up. So you're going to start seeing more fibers on the surface. You don't want to get on it while it's still bleeding, so to speak, because the fibers need a chance to anchor in that concrete to hold them in there. You also want to angle that broom bristle head down. You don't want to really be pulling at a 90-degree angle across that concrete because it'll start pulling fibers. You want to angle those broom bristles down as close to the surface as possible. Clean the broom head as much as possible as well. I've seen a lot of very good broom surfaces with fibers in them as long as you follow good concrete practices.
I think I've seen from our side, the biggest thing is misuse of fibers. Some say, oh, we need just to add fibers. And making sure you want a macro or microfibers and knowing what dosage to put in there. And some, just add fibers. And the intent was to add a macro fiber, but they only added a microfiber. So that's really one of the bigger things to review. A good reference would be go to ACI because it talks about in slab on ground as well as residential slabs. Actually, Fiber Design 544 is a good reference to start with. It gives you dosages and how performances are equated.
Mm-hmm. Yes, fibers can be used in numerous applications. I get questioned on a lot is decorative concrete being grind and polish. And with our macro fibers, it can definitely be used in those applications for grind and polish. I know I've done the Erie Art Museum in Erie, PA, the Queens Museum up in Queens, New York, and both of those used 7.5 pounds of macro fiber. And done properly, you can get a very good finish on the surface of the concrete. So we all, no matter what the application is, particularly though with grind and polish, we do recommend a mock-up first to make sure that the owner is satisfied with the depth of the grind and everything. But yeah, so fibers can be used in all kinds of applications.
Yeah, I didn't know about the polishing. Like I said, I learn something every time I do one of these things. I think that's a good spot for us to stop today. If we want to reach out to you all and learn more about Forta and fibers, are we reach out to Kristin, or we reach out to all y'all, or what's the best way?
Yeah, feel free to reach out to me. You can also find Forta on social media, LinkedIn, Facebook, Twitter. Make sure to check out our YouTube channel for best practices regarding mixing and finishing, as well as project videos.
All right. Well, that sounds good. Thank you all for coming on the podcast today. And we'll see you all on the next episode of the Concrete Logic Podcast.
Thank you very much, Seth.
And that concludes another episode of the Concrete Logic Podcast. I hope you got some value out of that episode and learned a thing or two. If you did, visit our website, concretelogicpodcast.com. Click on the Show Support tab and learn how you could be listed as a producer of an episode. Again, that's concretelogicpodcast.com. Click on Show Support tab to learn how you can support the show. And as always, Mike Dunton will take us out.
Ring, ring, that alarm always sings. Couple hours before the sun comes up. Open up the side, put some diesel in the lights, and wait till the trucks roll up. Yeah, this ain't how most folks live their lives, dripping in sweat, working overtime. But while they're tying their ties for their 9 to 5s, we're out here changing these skylines with wood, iron, and mud. We work hard for $1, give thanks to the Lord above. Never make a man do something you can't prove. Hard work calls for a drink or two. Expect more, it's written in our blood. With wood, iron, and mud. From the swamps to the city, from the Lone Star heat to the woods of the Georgia pine. Good old boys and girls who ain't afraid of getting dirty for a clean time. And if you want to see the fire in a grown man's eyes beneath the hot summer sun, find the wild-eyed boys clocking days and nights, working hard to get